Newton-Raphson. Okay, form of iteration, quite straightforward. You've got the formula on your formula sheet. So this tells you it's got a root between 2 and 3. Explain why if you take 2.5 as your starting value, your Newton-Raphson will fail. Well, your first suggestion of failure is that that's actually a stationary point to that curve. Right, so try that first. Differentiate the curve, you're going to have to anyway if you were going to do Newton-Raphson. Substitute in 2.5 and you do get 0. That means you've got a stationary point. So when you construct a tangent to a stationary point, it will be parallel to the x-axis and never touch it. Therefore, you will never get another iterate. It's failed. Or you could just think, if you look at the Newton-Raphson formula, if you do substitute in f dashed of your starting value and it's 0, it's undefined. You'd be dividing by 0. Another type of failure is not maybe as obvious. So again, we've got here another equation, ln x plus 0.2 over x equals 0, and that's got a root between 0.5 and 2. Why does Newton-Raphson fail here? So the first thing I do is I differentiate it to see if when I put 1.5 in, I get a stationary point. So there's f dashed of x, 0.8 minus ln x over x squared. I had to use the quotient rule. If I put 1.5 in there, I don't get 0. So my first iterate is not a stationary point. So you get your Newton-Raphson formula. So here's my Newton-Raphson formula. Okay, and I substitute in, ugly. I'm just going to use it. I'm not going to simplify it. I don't have to show it. So I put 1.5 in, and I do get out minus 0.8. However, if I now go to put minus 0.8 in there as an x value, I can't, because I can't take the log of a negative thing. It will be undefined, so I can't ever go any further than x1 is minus 0.8. It's undefined, therefore it's failed.